Hello friends, welcome to the video series on PLSQL performance tuning. Since this is the first video in this series, let us first understand how to start with the PLSQL tuning, because many times the requirements comes like the given procedure is taking more than 1 hour and you need to start tuning. So the biggest problem of performance tuning, that too specifically in PLSQL, is that you cannot start with a manual inspection of code, because the procedure may call another procedure, which in turn may call another one, and it can go for n number of PLSQL call. And so literally it is not possible for you to go through each and every line of code to check whether that particular line is taking more time or not. So this video will help you to understand where to start with the PLSQL tuning and how to identify the potential bottleneck in the PLSQL code. Because once you know the place where it is taking time, then you can start tuning that particular line. Suppose if that particular line is an SQL code, then you can tune that particular SQL, or if that particular line is an PLSQL code, then you can follow PLSQL tuning methodologies. So basically this video will help you to understand how and where to start with the PLSQL performance tuning. To ease the process of PLSQL performance tuning, Oracle has provided an inbuilt tool called DBMS Profiler. So basically I'll be taking you through this video to understand how to start using the DBMS Profiler and what are all the prerequisites you need to do to use the DBMS Profiler. So I'll be taking you to how to start with PLSQL tuning, what is a DBMS Profiler, and how to use the DBMS Profiler. And obviously I will be showing you a demo on all these things. First, let us start understanding how to start with the PLSQL tuning. See, typically what we will do is we'll just start with the manual inspection of code to check whether a particular line might take more time or not. This will work as far as the number of lines in the PLSQL code is very less. Suppose if you are tuning one procedure and it is not calling any other PLSQL unit, and if the number of lines in the PLSQL code is very less, then this may work. However, this may not work if there is too many PLSQL calls internally. There are another ways to find the potential bottleneck is like we can put enough log statements to capture the timing of each and every statement, so that by analyzing the log statement, you can easily identify where exactly the time is going or which particular statement is taking more time. So this also will work as far as the number of lines in the PLSQL code is very less, but this is not the most efficient way, because you need to keep modifying the PLSQL code to check whether a particular line is taking more or not. So instead of doing all these things, what we can do, we can use the provided tool called DBMS Profiler. So this DBMS Profiler is nothing but a package provided by Oracle to capture the information about the PLSQL code execution. So this is basically this is provided by Oracle to identify the performance bottleneck. So what basically this DBMS Profiler will do is this captures the information about the code and its runtime information, like how much time each line is taking and how many number of time a particular statement is being executed. So these informations are captured in a separate set of table. So after execution, what you can do, you can analyze these information to find which particular line is taking more time. So this is what I'm just going to take you through. Once you identify the line, then it is up to you how you want to tune it. Suppose if that particular line is an SQL code, obviously you can tune that SQL, or if that particular line is a PLSQL code like a looping statement or it's a cursor statement or whatever it may be, then you can go ahead with the PLSQL tuning methodologies. Fine. Now let us understand how to use the DBMS Profiler. So basically, to use a DBMS Profiler, you just need to follow 4 steps and exactly in the same order. The first step is environment setup. You need to prepare your environment to use the DBMS Profiler. So this is nothing but you need to create few predefined tables prescribed by Oracle to capture the profiler informations. So the second step is profiler execution. In fact, the first step is just one-time setup only. You are just going to prepare your environment only once. Okay, after that you don't have to do this environment setup for each and every profiler execution. Once the environment setup is done, you need to execute the profiler. So the profiler execution is as per your requirement, like any number of times you can execute. For example, first you can execute a profiler execution on a set of PLSQL code to capture its information. After analyzing the informations, you can tune that particular code. Again, you can execute the profiler to check whether it has actually improved or not. Fine. So this is about the profiler execution. See, I'll be showing a demo in a little while. So this is just a high level steps for you to understand what steps you need to follow. See, once a profiler is executed on a set of PL/SQL code, this collects some information and populates in the predefined table. So what you're going to do is you're just going to analyze the data. So for every profiler run, it collects some information into the PL/SQL tables. Then you need to analyze the data collected to identify where exactly the time is going. So this is basically an iterative process. You just need to keep running the profiler execution and data analysis for each and every subsequent execution of your profiler. See, once you have run your profiler and once you have analyzed the line, or once you have identified the potential line which is taking more time, then you can start with your optimization. So the optimization may be an SQL optimization or it may be a PL/SQL optimization. So this is at a very high level. Now let us see what we need to do in each and every steps mentioned here. First, let us start with environment setup. So environment setup is a very straightforward process. What you need to do is you need to check two things. One is like whether your user has the privilege to execute DBMS Profiler package or not. By default, most of the time when we create the user, it will have the default privilege to access this DBMS Profiler package. In case if you're not able to access this package, log in as a sys user, just give a grant privilege to this particular package to your schema. So the second thing is that you need to create the profiler table in the schema where you are going to run the execution. Otherwise, you can create one standalone, one individual schema. You can create these tables there and you can give the grant to all the other schemas also. Normally, I would suggest is you just create these tables in the schema where you are executing. Fine. To create the table, what you need to do is you just need to run a particular file called proftab.sql. So this particular file will be available in the Oracle installation directory. What you can do, you just go to the Oracle installation directory, search for this file called proftab.sql. You will be able to find a file in your Oracle installation directory. Just execute this SQL file. Basically, by executing this SQL file, this creates three tables. One is called PL/SQL Profiler Data, PL/SQL Profiler Unit, and PL/SQL Profiler Run. So these three tables will be created in the schema where you are executing this particular file. So these are the three tables which is going to hold the profiler information during your profiler execution. So this is about environment setup, and this is just one-time setup. For an schema or for a database in where you are going to execute your profiler execution, you just need to do this environment setup just only once. Fine. Once the environment setup is done, the next step is to start with the profiler execution. So profiler execution is very simple. It's just a three-stage process. First, you need to start the profiler. So the start profiler is just a marker saying that you are starting the profiler, so that from that particular point of time, Oracle captures all the line by line execution informations into the profiler table. After starting the profiler, you need to execute all the PL/SQL code where you want to collect the informations. That is where you want to collect the performance related informations. After executing all your PL/SQL block, all your PL/SQL code, you need to stop the profiler. So this is the very straightforward three-step process. To start the profiler, you need to invoke a procedure called DBMS Profiler.start profile. So this will be the API to start the profiler. After that, you can just execute whatever the PL/SQL code you want to collect the information for which you want to tune. The last step is like stop profiler. To stop the profiler, you just need to invoke the API DBMS_profiler.stop profiler. So start profiler will start the profiler. After that, any PL/SQL code you are executing, all the informations about the PL/SQL code will be collected into the profiler table. And finally, when you invoke the stop profiler API, it stops the profiler execution. Okay, now let us see how to do this environment setup. Then we'll proceed with profiler execution. So just search for, as I mentioned, just search for the proftab.sql in the directory where you have installed the Oracle. So just copy the entire path, execute this file. So basically what this file will do, this will just create the profiler tables. After creation, just check whether the tables are available. You will be able to see 3 tables in your user table data dictionary, that is called PLSQL Profiler Unit, PLSQL Profiler Run, PLSQL Profiler Data. Fine. So once the environment setup is done, then you can start the profiler execution. So I'm just going to show you a small demo of code. So what I'm going to do is, I'm just going to create 3 procedures. One is called procedure C, which is having some set of code, and this procedure C I'm just calling from another procedure called procedure B, and the procedure B I am calling from another procedure called procedure A. So basically when we invoke a procedure A, the procedure A will internally call procedure B and procedure B will internally call procedure C. So now the question is, if a procedure A, invoking a procedure A is taking more time, then you need to identify which particular statement in these 3 procedures are taking more time. Then you need to start tuning. So this is how we'll be identify which particular line is taking more time. Fine, let us first create these 3 procedures. So I'm just creating procedure A followed by procedure B followed by procedure A. Now all the 3 procedures are created. Fine. Now what we can do, we can execute the start profiler. Okay, executing the start profiler will start the profiler and it will start collecting the profiler informations of the PLSQL code, whatever we are going to execute after this point. So just execute the DBMS underscore profiler dot start profiler. So we are just executing the procedure, that is start profiler procedure. After that I'm just calling the procedure A. So now procedure A is being invoked. It's taking a little bit more time. Let it get executed. Like since there are like multiple loops I have included, like in fact I have had loops in all the 3 procedures. So finally the procedure C is going to call n number of times based on the number of loops you have mentioned in procedure A, procedure B and in procedure C. So obviously it will take time. Okay, now the procedure execution is completed. In fact, it has taken like 128 seconds. Fine. Now what the third step is, like you can stop the profiler execution. Just invoke the API DBMS underscore profiler dot stop profiler. This will stop the profiler. Okay. Now that we have done our environment setup, we ran a profiler on a particular procedures or set of procedures. And finally, we need to analyze the data. See, when a profiler gets executed, this captures the informations in 3 different tables. One is called PLSQL Profiler Run, PLSQL Profiler Unit, PLSQL Profiler Data. So Profiler Run will contain the information about 1 row for each execution. Profiler Unit captures the information about what are all the APIs or what are all the PLSQL units involved as part of the profiler run, like what are all the procedures, functions, packages, or whatever the informations that is called as part of that particular PLSQL run will be captured here. The PLSQL profiler data will have the information about line by line details, like how much time a particular line is taken in that particular unit and how many times that particular line is being invoked. So all these informations are captured in the profiler data. In fact, the profiler data is the core information which contains all the performance related informations. So all these 3 tables have common linkages like run ID and unit number. So using the run ID, so for every run there will be one run ID generated. So using the run ID, you can join PLSQL profiler run and PLSQL profiler unit table. Same way you can use the run ID to join PLSQL profiler run table and PLSQL profiler data table. And using the unit number, you can join the units table and the data table. So by combining these 3 tables, you can get the information about how much time a particular line is taken in particular program unit. See, now that we have just executed on our demo script, let us collect these information to see which particular line is taking more time. Okay, so before that, I just want to quickly run through these 3 table information. So the PLSQL profiler run will have the information about how much time that particular overall execution is taking. So for every run, it will capture the information about one row with an run ID. Okay, so this basically captures information about the run comment, whatever the comment you are mentioning as part of the start profiler, and whatever the total time this has taken. So the units will have the information about what are all the units involved. So obviously some anonymous blocks will be there because we just executed from our SQL developer, which internally called procedure A, procedure B, and procedure C. So this basically assigns some unit number to these things. Against these unit, the informations will be captured like in the profiler data. You can see against each unit it captures some information like total number of occurrences, that is how many number of times a particular line is being executed and how much total time that particular line has taken. So these two are the two key informations which will help you to identify which particular line is taking. Now what you can do, you can just join all these three tables. So I've just joined all the three tables based on the column whatever I have mentioned, and have just sorted as per the descending order of the total time. As you can see here, the line number 5 in procedure 3 has been executed for 1,25,000 times, and the total time taken is mentioned here. Okay, so I've just computed the percentage also here. As you can see here, 97% of the time is spent in one particular line. Okay, so this is how you need to identify which particular line is taking more time. So instead of browsing through the entire lines of code, or instead of tuning all the PLSQL codes in your procedure, now you can just concentrate on only one line. See, again, one more key information here. You should not just concentrate on a line just because it is taking more time. Another thing you need to check is the total occurrences, because sometimes the total occurrences will be very less, whereas the time taken will be very high. So those are all the potential lines to start with the tuning. So this will just give you some idea where to start with, or this will give you an information like where exactly the time is going, so that it is up to a developer to decide whether that particular line is a potential candidate for tuning or not. So one more thing, so whenever you want to just delete the information from profiler table, just follow the same order. You start with profiler data, then delete the profiler unit table, then delete the profiler run table, because these three tables have the primary key, foreign key linkages. So if you follow any other order, you will not be able to delete the informations. Fine. Now that we set our environment, we ran profiler execution on a set of procedures, and we have got the data, and we are analyzing the data to identify which particular line is taking more time. So once you identify the potential line which is taking more time, and the last step is like optimizing the PLSQL code. In fact, the last three steps, that is profiler execution, analyze data, and optimization. So all these three are like an iterative process. So for every changes you are doing to the PLSQL code, you just need to re-execute the profiler execution, collect the data, and optimize the PLSQL code. When it comes to optimization, see, there are many ways to optimization. I just want to highlight the points. Probably we'll see in detail about all these points in subsequent videos. So these are just a high level, and in fact there are a lot other ways to do the PLSQL tuning, but these are just to give you some understanding about how to start with, or what are all the things available to do the PLSQL tuning. Many times in our PLSQL code, we are just doing the PLSQL way of implementation, even though there is an equivalent functions available. So instead of doing a PLSQL implementation, wherever there is an inbuilt functions or analytical functions available for that particular functionality, make sure you use that so that it improve the performance. So the next thing is like bulk collection. Whenever you are working on a collections, and if you are doing a traditional looping to load the data or to insert the data, instead of that, try bulk collection, which will improve the performance. Wherever you want to store a huge amount of temporary information, use the global temporary tables instead of putting it into a variables, so that this might improve the performance. Instead of writing multiple statements, merge all these statements into a single statement wherever is possible. Use insert upon hint to improve the performance of insert statements. Use the no copy compiler hint to pass by references, and consolidate the redundant code, because many times what happens is we would have delivered some code to a production, and any smaller changes or enhancement to the code, we'll be writing an additional set of select statements or whatever the statements. Many times it is possible that we can reuse the existing statement itself, but instead of changing the existing statement, we just keep adding some new information. So this may introduce few redundant code. So instead of that, what you can do, you can avoid this redundant code, make use of the existing code itself, which might improve the performance. Reduce the usage of lob variable, use it only if it is needed, or only in case it's not able to handle through the scalar variable. So these are just a few pointers. Probably we'll see about all these things in the upcoming videos in the same series. I just want to show you how this PLSQL performance helped me to improve a performance in one of my projects. I just want to show you the real-time data so that it help you in improving your code also, and in fact you can follow a similar methodology also. So what I would suggest is, before starting with tuning, you just do a plain PLSQL profiler execution and capture the informations. For example, in this case, this is my profiler information of my first run. I'm just capturing the information like how much time a particular code is taking, and I'm sorting by the total time taken, and I'm picking the top 5 categories. So whatever I am comfortable with, I'll start with the tuning. After identifying a potential line for performance tuning, I'll do the changes in the PLSQL code, and I will do the second execution. So in the second execution, again I will sort it by time taken, and again I will take the top 3 or top 5 informations. Again I will capture the information. Again I will do the performance execution. So the run 3, the same thing I will be reiterating. So don't delete the data in the table. Instead, you just keep the same informations, so that at the end of the execution, you can collect all this information to check how much you actually improved. So this is my run 3 data. And finally, after putting again few more improvement statements, or after deploying few performance related changes, this is my data of run 4, where I am seeing a potentially good improvement. And finally, after all my changes, here is my run 5 statement, run 5 performance numbers. So I would suggest you capture like this, do an iterative performance tuning, capture all the information. You can capture an Excel sheet, or you can store it in the table itself. Finally, what you can do, you can just check how much you actually improved, because when it comes to a performance, after doing all this hard work, you need to present how much you actually improved and what you did to do this improvement. For example, what you did for run 1, what are all the changes you did for run 1. Same way, what are all the changes you did for run 2. Same way, what are all the changes you did for run 3, run 4 and run 5. So this type of presentation will help you understand the iterate. One is like an iterative improvement. The second is like which particular tuning methodology helped you, because it's not necessary that all your changes would have improved. So whatever it is not improving, in fact, you can remove that. So whatever the changes has actually improved the performance, you can just keep it, and you can present it in a better way for better understanding. So all the scripts, whatever I have showed you here, are available in this blog link for your reference. If you have learned something new, please like this video, subscribe and stay tuned for new feature video, interview question, SQL practical question and concept videos. If you want any questions to be answered, you can post it in the comment section, or you can drop to this mail ID. And thanks a lot for watching this video.